Welcome to qnawire.
In this problem of Laplace transform, we have given the figure. Let me show you. So this is the figure, and then we have to find y the function of t is equals to x, function of t is multiplied with, this is h the function of t, for each pair xt and ht. So here we have xt and ht. So first we can say this would be the condition for the value of t is varying from 0 to 1. We can say x multiplied with t minus lambda, and this would be h lambda. So this is t minus lambda and h lambda overlaps. So let me show you the overlapping figure. So here, as you can see, this is f1 t minus lambda, or we can say this term is x of t minus lambda, and here this is h. So this is h of lambda. Now here this is the figure, and we can write it as yt is equals to, this is xt is multiplied with, this is xt is multiplied with h of t. So this is ht, and when we solve this term, so this is equals to integration from the limit 0 to 1. So here this is the limit integration from 0 to 1, and this would be from 0 to t. We have to put the value, say is from 0 to t. So we have to put the limit, say from 0 to t, and this would be 1 multiplied with lambda is multiplied with d lambda. So integration is lambda square divided with 2. Now we have to put the lower limit and upper limit. So this is equals to t square divided with 2. Now we can also say this is the figure B. So you can see the figure, the value of t is in between 1 to 2. Then say this is x of t minus lambda and h of lambda overlaps. So here we can say y of t is equals to integration is from t minus 1 to t, and this is 1 multiplied with lambda of d lambda. So here this would be again say, and this would be plus also. So this is plus also, plus this would be from the 1 to t, and this would be 1 multiplied with 1 is multiplied with d lambda. Now when we solve this, so integration of this term is lambda square divided with 2, and this would be taking the upper and lower limit. So we are getting the term which is minus t square divided with 2 plus 2t minus 1, and for t is greater than 0, for t is greater than 0, this would be for t is greater than 2 actually, there is a complete overlap, so that this would be y of t is equals to integration from t minus 1 to t, and this would be 1 multiplied with 1 multiplied with d lambda, that means this is simply d lambda is equals to lambda. We have to put the lower limit t minus 1 and upper limit t, so we are getting this is simply 1. Now we can write the function y of t. So y of t is equals to, this is t square divided with 2, for the value of t is in between 0 to 1, and this is minus t square divided with 2 plus 2t minus 1, for the value of t is in between 1 to 2. And now if t is greater than 2, we have equals to 1. So this is equals to 1 for the value t is greater than 2. So this is the answer for this part, and similarly we have to find for the second figure. So here is the figure, let me show you, and this is the part B, and now we have given xt here and ht here. Now we have to find yt, which is the multiplication function of xt is multiplied with ht. So when we do the overlapping, so here is the overlapping figure, let me show you. So here is the overlapping figure, let me show you. So this is the overlapping figure, and from this overlapping figure we can write the term which is for t is greater than 0, the two function overlaps as, say this would be yt is equals to xt is multiplied with h of t is equals to integration from the limit 0 to 1 and 1 multiplied with 2, and this would be e to the power minus lambda is d lambda. So when we do the integration, this is minus 2 and e to the power minus lambda, we have to put the lower limit and upper limit. So this is from 0 to t. Now when we solve it, so we are getting y of t is equals to 2 multiplied with 1 minus e to the power t for the value of t greater than 0. Now we can write the term which is, say y of t is equals to, this is 2 multiplied with 1 minus e to the power minus t for t is greater than 0, and now we have to talk about only for the positive value. So this is the right answer.